Let's start the show and tell who has a robot that they want to start with. I'm going to let this person go first. We're going to be trying to experiment with wiring people up with the boom mic so that they can talk and be heard.
I've got 2 robots.
You got 2 robots, that's fine. Let's see if this works.
Do I show them separate?
Okay, go on.
I'm going to do one after another. What is that?
That's just like, just talking.
I don't want to.
Try it.
I'll talk this way.
It's okay. Is it working?
Does it work?
We'll find out.
Testing.
Turn it on. There we go.
Testing. No. Not yet.
Okay, just put it to the side.
Just put this on here for my
Okay.
Do I have to show this one on the table?
Do it however you want.
Okay, I'm going to show Yes.
Put it on the
That one's Yes.
You're moving. So what does it do?
I don't think you can hear it.
It's okay. Bring it over here. Make it fun.
I'm running it.
I didn't see where we're going. No one's getting. Okie dokie. Let's record a program from the airport.
I'm going to have it find the beacon.
Oh yeah, Google. Where's the beacon? The beacon's the remote.
Okay.
Right there.
It's like camps with the
Oh. Oh my God.
Wow, I like it. That beacon thing.
like that one. Yeah.
Where is that beacon?
Okay.
There's that beacon. Right here. Where is that beacon?
And then it has our remote right there.
Hey, look at the road.
I'm going to show the other one.
Are you gonna do? I guess you can just keep it watching. On the laptop. So do you just like? Are you gonna do that?
Yes, Jay. What happened? Is it still on? Okay.
That's a nifty gadget.
Alright. The light sensors aren't working right now. They're right here in the eyes. So when you turn it on, it'll go forward, stop, go forward, stop, while the music plays.
Check that out. Kind of like Spider said. You know what that is.
Oh, but it has a volume control. It's under. There. It's under there.
Very good. Do anything else?
No.
Okay, good. Thank you very much. So who's next?
checkered out.
I know.
Floor first.
Does it work? Oh, there. This is a robot alligator. It's called Robogator. And my sister did the jaws, and she tested it out. So my sister will explain it.
I did the jaws, so this motor sensor controls it, and I tested it myself. And its jaws snaps 5 times, and it worked.
There you go.
So now I'll run the program I did. So. No. So it's like, it does this. So like if the object is within less than 60, if the object is less than 60, then it'll start moving, and then if the object is less than 35, it'll start snapping its jaws. If the object is less than 35 centimeters, it'll start snapping its jaw.
All right. See that? Look good. Very good. That's awesome. Does it do it?
Go back. So that's what it's supposed to do.
Most excellent. Thank you very much. Okay. I'm going to do you after this gentleman right here in the black. Okay.
You might want to move him back here. I could move him a little bit. Thank you very much. Pardon? I'll take it. No problem. Back up when he needs to.
I'm here. So this is my tabletop robot. It's running Linux on a Panda board, and then it's also connected to a baseboard, which is a robot controller connected to Linux. It controls motors and input from these limit switches and this ping sensor. So I've just finished stage 1. I'm working on the stage 2. I've just gotten the ping sensor working, so here's a little demo that I put together. And it, as you can see, it tries to stay the right distance away from my hand, between 3 and 6 centimeters. And then here's also my stage 1 program. but Osmond helped me with the Linux problems, but...
Yeah, okay, that's kind of what I thought. Okay, I'm going to take the mic off. Who's next? I love it. Okay, I'll try.
Testing, yay. So this is the TurboBot. You may have seen it before. It's basically, it's like a TurboBot, but it's not a TurboBot. And
How do you want to do this? You know what? I'm going to take your laptop over.
okay.
Drive over.
And here it is. And I wrote some nodes, ROS nodes in Python to drive the robot around with the joystick and this missile launcher thing on top, which I think is really cool. And
So what's new since last month?
new since last month, we actually got the teleoperation of the robot working with the joystick and not just the missile launcher, so I no longer have to use the keyboard to drive around the robot. And we also have some sounds that I can play from here.
Okay.
Look, the sounds are coming on. Look, they have the
Yeah,
on my lap. Is that that
Well,
one that we have?
Yeah.
We were going to, do you want to do that?
Okay. Yeah. Yeah, can you please go with the notebook?
Oh, the notebook. Sounds aren't fully integrated yet, so
And if I don't have a notebook, I'll forget how to do it.
so I'll give you the. While she's looking up the notes, for those of you that didn't see it last month, one of the features we put on this is our monitor, and we have a little Pico projector on here. And you probably there it actually came up, but you can see you get a dim, blurry picture, but at least you have some kind of a monitor. Kind of the idea is if you need to debug something, you just drive up close to the wall and turn the projector on. And look at it. So you ready to go? Okay. Is there a question?
Yeah.
Okay, I think we didn't bring up all the ROS nodes necessary for speech, so I think we'll wait until next month or something when we have that more fully integrated. But you haven't shot anybody yet.
What?
You haven't shot anybody yet.
Okay, who wants me to shoot at them? Okay, sure. I'm really not good at aiming, so I'll try.
Oh, it's going to me. Go over it.
There we go.
Awesome.
Are you ready?
Just me.
You got a pocket. Don't have a pocket size.
So last time I made a robot. Yeah. left it over here. But yeah, I made a robot, and that was my first time working with the ROS. And now I kind of expanded ROS. I added a Android smartphone into the mix. I added a Android smartphone, and so what this does is it's like a remote control, except instead of just like your normal remote control, it doesn't just send commands to the robot. It also receives the status of the robot. So, this is communicating to the laptop through Wi-Fi, and the laptop's communicating to the robot through this little XP thing. It creates a wireless link. There's another one over here. So, as you can see, the robot I can control forward and backward. The status part isn't fully integrated yet, so sometimes it doesn't show up. So, it wrote on the screen forward every time it went forward, and every time you stop it, it stops. And I don't know if you can see this, but it's saying forward. And when you lift it, it says stop, like I'm gonna fall off, so stop. So yeah, and that's pretty much it. I can show you how it's working. For those of you who don't understand this, that's okay, but so basically what this is telling me is that on the computer it's showing me all everything that's going on. So right here, that's my it's saying my Android phone is talking to the robot, and the robot's talking back to my Android phone. So that's what's showing up on the screen. So any questions?
Do you have any help?
Yeah, I had a little help with the ROS Java compilation.
Okay, that's good. You notice how ROS is starting to take over the club now, so very good. Thank you very much. Who's next? Tim.
This is not a robot. The Raspberry Pi enthusiast, the Raspberry Pi user's guide is now available. Mine arrived from Amazon this morning. I haven't looked at it, so I can't speak to its quality. It's some of the little bit of documentation that's currently available. List price on the jacket says $20. I think it was like $14 at Amazon.
How many people here do not know what a Raspberry Pi is? Good, we got it. Oh, we got it again. Raspberry Pi is a $35 computer that runs some flavor of Linux. And it's basically designed for educational and hacking purposes. To give a price point, back when I got started in robotics here, we were using basic stamps, which are very primitive microcontrollers. They cost $50 each. So, we've had a huge improvement in the amount of computation we can put on our robots. Okay.
I was just wondering, I don't know if anybody knows, but I was wondering what that book is that the wiki wouldn't do.
It's hard to hear you.
I was wondering what the book is that the wiki does not get, the Raspberry Pi wiki.
I think it's been announced on I saw it on the Raspberry Pi mail list. So, I may not have heard your question properly, but I think that's what you asked.
Why is that?
Okay. Is this the next robot that's moving into the scene? Whose is this? It's Cam. Okay. Would you like to tell us what you're doing, Cam? It's a smart table.
This is Dino XP11, and computer velcroed to it. And actually, this is the same thing we did with the challenge last month, which reminds me that next month is our Phase 3 challenge, and so this is our opportunity to show what we've made. And so, dust off your robots, charge up your batteries, bring them out. And the meeting next month is moved back 1 week, so not to conflict with Halloween. And Halloween's just a really excellent robotic holiday, animatronic. So I mean, if you need a reason, to build robots, what else is there to do, right? But Halloween's just a great excuse, and it's a lot of fun, and it's actually a good value. My skeleton, Scully, he's like 3 years old now, and you just bring him out every Halloween. It's a lot of fun, scare the heck out of kids and stuff. But anyways, so this is the Nito XP11. I've got the computer here telling it what to do using ROS, and I actually managed to deliver a package in the office today. I thought that was pretty awesome. Next month is our Phase 3 challenge, and so let's get those robots out and bring them out and have some fun. Thank you very much.
Thank you.
Hi, great robots, by the way. My name is Grant Mars. I don't have a robot, but I just got a patent. And my patent's it's called a timestamp neural network. For you kids here, a neural network is kind of like a bunch of cells, and you connect them together. You have the input cells and the hidden cells and the output cells, and you have multiple multipliers between them, or weights, and you sort of put some input in, and then you have an output, and then you kind of mess around with the multipliers until you get an output that you like, and you keep going. That's a neural network. And then there's another sort of more esoteric thing called a spiking neural network, or a pulse neural network. And that's more like your brain. It has pulses that go from one cell to another. It's much more like brain tissue, where you have a signal traveling down through the axon of the soma to the axon to the dendrites and so on. So my invention is I get rid of the pulses, and the cells are just broadcasting when the last fire. They say it's a timestamp, it's a number that all the other cells can possibly see, and you have an algorithm that you also play around learning where the timestamps, you get a bunch of timestamps coming into one cell, and if you get enough of them, that one updates its timestamp, and so on and so forth throughout the whole network. I did the whole thing on an FPGA. That's a field programmable gate array. I need some help. I'd like to put it on different platforms, maybe even a supercomputer. If you have any supercomputer people here, probably not. And I also wrote this patent, so I feel like I have a little expertise. I might be able to lend other inventors in their progression toward the patent themselves. Thank you very much. Well, I'll be here so you can talk to me after the show.
Thank you very much. Okay, how many more robots do we have tonight? Is that? Looks like we got another. Boris, let's go for it. What?
Okay, so this is what I currently have for my Magellan robot. It took me a month to make, but nothing's really working right now. I've got problems all over the place, but at least the compass works. That's all that works right now. So
there's always next month, which is the third phase of the HBRC Tabletop Challenge. Okay. Any other